What? Here we go, finally. Ah, good. Going over last night's quest, taking a look at some problems. We were taking a look at zeros and x-intercepts. Zeros are when a function has 0 as the output, and an x-intercept is when a function crosses, the graph of a function crosses the x-axis. And so both zeros and x-intercepts are talking about exactly the same numbers, but one's talking about it from the function and kind of algebraic perspective. The other's talking about it from the graph's perspective. But to be honest, I'm kind of okay if you use both terms somewhat interchangeably. So here we go. If I want to find the zeros of the function, well, zeros occur whenever the function outputs 0. And so this function, g of x, I'm going to replace the output with 0. And then try to solve, which at this point, solving this, we only know how to do that one way, although there are multiple that you'll eventually learn. We'll solve this by factoring. And so notice the leading coefficient is 1, and so I don't have to use AC method, although I am permitted. So I'm going to find the factors of the C term and figure out which of those subtract to be 5. So 1 and 24, 2 and 12, 3 and 8. Oh, ding, ding, ding. 4 and 6 runner-up. Boom. And so I'm going to have 0 equals... Oh, man, my tablet's been wonky lately. That's bizarre. X with a 3, X with an 8. Come on. Come on, tablet. They multiply to be negative 24, so their signs are different. And they add to be a positive. So different signs adding to be a positive. That means the bigger of them had to be positive. And then we also learned a trick that, yes, I could zero product property and set each of these equal to 0, but we realized that as long as there's no number in front of the x terms in these factors, the zeros are simply going to be the opposites of those numbers. So x with is just 3, or x is negative 8. And these are the zeros of the function. Tell you what, let me find that white text. Yep. And so we're kind of speed running here. We just do the opposite of that in order to figure that out. So that's not that bad, right? Not that bad. Hey, here we go. Look at this. I like the orange on the black theme. It looks real good, real good. So let's see. The intercepts here, let's do this, are going to equal negative 5 and negative 3. Zeros correspond to the x-intercepts. And so which of these parabolas, boom, negative 5, negative 3, right there, right there. So 31 is delta. For this, the zeros would be, pardon me, I've got a granola bar crumb in my throat. Nature's valley. And then I've got a positive 3, opposite. And let's see, so negative 5, nope, that's positive 5. Nope. I'm suspicious of this one. Let's count these out. So these are counting by 2s. 2, 4, and negative 5, and 2 and 4. So yeah, 3. Looks like F, Foxtrot, is the answer to 32. And over here, opposite, X is 5. Man, you can do these ones so quick. You just do the opposite trick. They were already factored for us even, eh? 5 and negative 3 looks like Charlie right there. Right there's my new... Oh, that's the negative 3. Yep. And the positive 5. Excellent. All right, last question. Boom. Man, this is going to be a brief video, says the guy right now, but just you wait. All right, use the zeros to graph the function. So what that's going to mean is I'm essentially writing this in intercept form, and so I'm going to factor this, and there's no number in front besides an invisible 1 for my squared term. So let's factor 1 and 18, 2 and 9, 3 and 6. Which of those add to be 11? That's the 2 and the 9. Now, yeah, I could just write an x with a 2, x with a 9, minus. But tell you what, I'm going to AC method because it's been a minute since we've done that. And so this is the long way around. But hey, I already said this video was so short. I might as well enjoy this. So I'd have a 2x and a 9x, and then the plus 18 And yeah, they got to combine to be negative. They're going to be minus minus in this case. Then I would GCF the first two. You guys remember AC method? Good old AC method. Here I'm going to factor out a 9, and better yet, take that minus sign with it, because I'm never going to leave the first term that I'm GCFing as a negative. Never, never. And so I'll have an x with something and a negative 9 with something. Remember to write your sign there when you're doing your AC method. Looks like x with a 2 and an x with a, negative 2. That checks out. That checks out. And so final form, Super Saiyan, x with a negative 9 and x with a negative 2, which is the same thing I would have gotten if I'd just speed factored, which you can do anytime your leading coefficient is 1. And so therefore my zeros are at 9 and 2. Did I give myself space for that? Yes, I did. So the zeros of the function correspond with the x-intercepts of the graph. And so here's a 9, here is 2. Let's find some h, shall we? So h is going to be the average of those things. We called those like p and q. I'll tell you what, I'll write p plus q all over 2. You don't have to write the formula every time, but hey, I was already there. 9 plus 2. Oh dear, it's going to be gross. It's going to be fraction-y. That happens though. About half, well, if I have integer intercepts, half the time you would imagine they would be odd when I add them together, and half the time they'd be even. So yeah, about half the time they'd end up being fractions. And let's see, so that's the same as 5.5. And so yeah, that seems to be legit. But the problem is I don't know the y value of this vertex. All right, well, let's figure it out. So k, I'm going to take the original function and plug in this 5.5. And yeah, I'm reaching for my calculator. I've got a kind of white and green TI-30X2S I'm sporting today that my son got for his birthday. The color combination, oddly enough, reminds me of stormtroopers from Star Wars, is what I'm thinking about today. Which, with this whole coronavirus thing going on, yeah, my family, we've been watching lots of Star Wars movies lately. Our kids' first experience, to be honest. It's been pretty fun. So let's see, 5.5 squared. I'm not going to know that off the top of my head. 30.25 minus 11 times. All right. This is riveting calculator data entry. 60.5 plus 18. Oh, here we go. And let's see, so k equals 30.25 minus 60.5 plus 18. I'm getting negative 12 and a quarter. And so let's plot that. Negative 12 and a quarter right there. And so tell you what, I'll even label the the point there. So there's my vertex. Now, question, if I want 2 more points, which I mean, really, right now I've got 3 points. Let's just do the quick slopes trick. A equals 1. And so my slopes are 1 over 1, 3 over 1, 5 over 1, etc. Here I am at negative 12 and a quarter, and I go up 1, that's going to bring me up to 11 and a quarter. And then I'm at 5.5, and I go over 1, that's going to bring me to 6.5. I could mirror this point over here as well. And then if I wanted, I could go up 3. And so, oh dear, let's see. So that's 1, 2, 3, and over again. I'm landing at a quarter down on this. Quarter underneath whatever this line is. Looks like negative 8 and a quarter. And I'm at 5, 6, 7.5 is where that is. And that'll do. I don't need to get crazy. Really, as long as you got 5 points for your parabola, you're doing pretty good. And look at that. Draw some pretty little arrows on that too. All right, so that is a way you can graph using the zeros. They're pretty quick to find, right? It's related to factoring. And although in the future, like I said, there will be multiple ways that we can figure out how to do this. All right. Thanks for watching, everyone. May the force be with you.